Hello everyone. Okay, so today I'm going to be discussing a crash course for 0606 additional maths on coordinate geometry. So basically, coordinate geometry is the discussion of the equations and intersections of lines and curves and geometrical figures on an xy coordinate plane in a Cartesian coordinate system. All of the lines and curves that we will be discussing today are of two variables of x and y. Right, so I will begin with the presumption that the viewer has already known some of the algebra basics that would normally be taught in secondary 1, secondary 2. In other words, basic algebraic manipulation, some basic concepts of algebraic fractions and algebraic formulae, including the change of subject of an algebraic formula, and that I will presume that the viewer has already known how to solve linear equations and quadratic equations in one unknown. Quadratic equations meaning by factorization, by completing the square, by the quadratic formula, and that I will presume that the viewer has already known how to treat a basic understanding of fractional equations, where there are algebraic fractions with variables to be solved, and that the viewer has already known how to solve and interpret the basic linear inequality as well as a basic understanding of solving equations in quadratic and linear form. Right. Today's discussion will be based on curves that are of linear or quadratic nature. In other words, all the curves that we will be dealing with today have a maximum power of 2. Some of the stuff that will be discussed today is part of IGCSE Normal Math 0580 Extended. Other parts of what I will discuss today are more geared towards additional maths 0606. Right. we will begin with a simple discussion on Cartesian coordinates. So in the Cartesian system, we have the y-axis, which is the vertical, and we have the x-axis, the horizontal. A point on an xy coordinate plane is always described by their x coordinate first, then their y coordinate. There are many different types of figures, lines, curves that can be represented on a Cartesian plane. Like, for example, this is an example of a curve that you might sometimes see on a set of Cartesian coordinates of integer coordinates x and y. Also a quadratic curve can be drawn on this type of curve, on this type of coordinate plane. The simplest type of geometrical figure that is discussed in coordinate geometry is the straight line. So, and in a straight line, the x-intercept is the point where the line cuts the x-axis. The x-intercept has the property that the x-coordinate is constant. It can be any value you like. The y-coordinate is 0. The y-intercept has the property that the x-coordinate is 0. The y-coordinate is the one that has its own specific value. The point 0, 0 is often referred to as origin O. Back to a straight line, right? We will now define, say there is a point A at the end of the line and a point B at the other end of the line. Right. We will define the midpoint as the point right in the middle of A and B, which would be, in other words, defined as the average of the x coordinates of A and B as the x coordinate of this midpoint, and the y coordinate is basically the same. And we would often call this with big letter M. The slope or gradient of the line is essentially just a way to say how steep the curve is, and the gradient which we call little m, is y1 minus y2, the difference in y over the difference in x. Again, for midpoint gradient, doesn't matter which y1 and which y2 you choose, because the gradient of the line AB and the line BA is, of course, just the same thing. Okay. To find the length of the line segment AB given the coordinates, well, say we have, and the first one again, the first point again has coordinates x1, y1, and the second point has coordinates x2, y2, then essentially the length is simply just x2 minus x1 squared plus y2 minus y1 squared, and then you square root the whole thing, and then you take the square root of the whole thing. And basically the whole idea behind this lies in the neat trick that actually the distance between 2 points on a line on Cartesian coordinates is basically just how much x you traveled, how much y you've traveled. Yes, you would obviously have noticed by now that this is just Pythagoras theorem in disguise. In a straight line, given the y-intercept m and given the gradient m and the y-intercept c, then you can make a general equation for any straight line of it being in the form y equals mx plus c, where m is your gradient, your slope, and c is your y-intercept. Again, the point 0, y on that line. And by substituting the coordinates of the point given, usually they will give you one coordinate which lies on the line, and that will be enough given the gradient to substitute everything, and you will get your y-intercept, and this will allow you for your equation of your line. Okay, so now we've got our straight line, like so. Right. Now we draw a second line parallel to the first. And guess what? This is actually just, if we think about it, this is actually just a vertical transformation of the exact same line. So in other words, the gradient never changed, because you're essentially just moving the line down a few units and you get your parallel line. So for parallel lines, M never changes, it's C that changes. For perpendicular lines, for lines that are perpendicular to one another, this is a slightly more advanced concept. The whole idea behind it is that the second line that is perpendicular to the first, when the gradients of both lines are multiplied together, you get -1. So basically, you just have to find the negative reciprocal of your original gradient to find your perpendicular gradient. And this, alongside your midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2, then allows you to find the coordinates, find the equation of a line perpendicular to another line and passing through the midpoint of that line. And as you can see, geometrically speaking, these two lines have the same length. Since these two lines have the same length, then this is a perpendicular bisector, geometrically speaking. And basically, since you already know your gradient, this is your perpendicular gradient, and then we know that, and we know our x and y from our midpoint, then we can find, of course, the equation of the perpendicular bisector. Okay. Right. Okay, so that's all the stuff you need to know for chord geometry of one line. Except Cambridge isn't going to make it so easy for you. What I mean by that is, well, what happens if they add another line? Well, really there are 3 different scenarios. This is a slightly more advanced concept. Actually, this is an application you would more often see in Math Olympiad or something like that. If the 2 lines are not parallel and they have distinct equations, then they meet at one point only. And this can be solved using your simultaneous linear equation, which you can solve using either substitution or elimination. Basically, this is how you would find the coordinate of intersection of any 2 lines. If the 2 lines are indeed distinct and non-parallel. From the discussion on parallel lines earlier, you will obviously know already that the parallel lines will never meet, so there are 0 intersections. This is case number 2. Case number 3 is a very unique one. This is best described using some kind of scenario. right, say we have something like this. Say we have something like this. Say you have these simultaneous equations, simultaneous linear equations. Well, let's try eliminating this. Let's try solving elimination. You multiply this by 2. Guess what? You get this equation. So so both equations refer to the same line. And that means, say we input x is 3, y is 1. Yeah, that's one solution. X is 2, y is 3. Hey, presto, that's another solution. Because the equation in the second line can be derived by multiplying everything, all the coefficients in the first linear equation by the same factor, the same multiple. So really, these refer to the same line, and so there are infinite solutions. Okay, yep. So moving on, we will now discuss more simultaneous equations. Except now, we won't have two linear equations. We're going to have one quadratic, one linear. This is something that often comes out in A math, and oftentimes they will put one of these questions in normal math extended paper form, especially because some of these numbers can get a bit messy sometimes. The whole idea is that you express the linear equation as y in terms of x in terms of y, whichever one you prefer, whichever one is more convenient. And then you substitute that value into your quadratic curve. Right, now you have a quadratic equation in one variable. Of course, it's a quadratic equation, so there are two roots. There has to be two roots, because since this is a quadratic linear system, there could be not one but two solutions. Actually, it could be 2, 1, or 0 solutions. A bit more on that later. To discuss that, we are actually going to have to discuss the quadratic inequality first. Well, basically this is a quadratic equation, but we will replace the equal sign with a greater than or less than sign. And what happens now? Well, for the case where it's greater than, so the curve looks like this, right? Yeah. So say this is the first root, this is alpha, this is the second root, this is beta. Then the solutions are x less than alpha and x greater than beta, because those are the parts that are greater than 0. If you think about it, this part is not taken into account because it's clearly less than 0. Yeah. And again, the same thing for your second case. If it's less than 0, then this is what I would want. And that would be alpha less than x less than beta. In some ways, this is basically just your in some ways this is basically just your idea that you must find the vertical values, the roots, and then from there it's best to draw a small sketch of the curve, so that you can see which regions that are included and which regions are excluded. Yes, we have this out of the way. We can now discuss the quadratic curve intersecting with a line. Right. The simplest version is with the x-axis actually, and this actually gets itself from the quadratic formula. Right. So minus b plus minus root of b squared minus 4 is equal to 1. Well, if this guy is less than 0, then there are two solutions, two roots. Yes, why two roots? Because it could be plus, it could be minus, right? If this is real, then there are two solutions, obviously. If this is equal to 0, square root of 0 doesn't count. Square root of 0 means 0, right? So there's one root only. And actually we know that there's a general solution for that. It's minus b over 2a. And then if it's less than 0, oh, that's less than 0. There's nothing that a square that's less than 0. Some might say. Well, there's a definition for that, but again, that is not needed to be known for this level. So really, we can write that. Yes, we can write that. No real roots. So we can write no real roots. Yeah. Okay. Now, what if that line is not the y-axis, but it's a slope line like this? Right. This is the classic simultaneous equations problem. Right. Well. Yeah. Well, again, you will have to solve it simultaneously, and then you will get an equation in terms of y or in terms of x, which is equal to 0. Right. Let's denote that EQ. Well, what happens? Well, if your line if your equation has the property that b squared minus 4ac is 0, again, all the equations are x squared plus bx plus c, right? in some way. Yeah. The well if x is well if the equation is equals well if b squared minus 4ac is 0, then what? Then there if it's equal to if b squared minus 4ac is 0, then there's one solution, and actually that solution is a tangent line. Intersects at one point only. Right. Those who have watched the differentiation video will know a bit more on how this works. When b squared minus 4ac is greater than 0, then we have two intersections. And then of course there's a case that it's less than 0. B squared minus 4ac is less than 0. Well, let me just show you using a little drawing how that looks. Yeah. As you can see, the curves will never meet, no matter what. Yes, and this is your third condition. So basically, all of the conditions for simultaneous equations involving a quadratic and a linear equation have three scenarios. All right. Yes. And you will have to be able to differentiate between one of these three scenarios during the exam. Yes. Okay. So here's an example of how that would work. Right, wait a minute. And so this question is basically an application of that b squared minus 4ac term in your quadratic formula. Anyway, we would call that the discriminant because it discriminates between 2, 1, and 0 solutions. The way you would solve this type of question is in the following steps. Number 1, you would solve this the way you would solve a normal simultaneous equation in terms of x and y, where one is quadratic and one is linear. So in this case, 2x plus k plus 2 equals to 2x squared plus k plus 2x plus 8. And now, what we're going to do is that we're going to move everything to the other side so that we have one equation, the other side 0, in terms of x and the constant k. And in this case, that would be 2x squared plus kx plus 6 equals to 0. The the equations have two distinct solutions. If this solution right here, if this equation right here has two distinct roots, so that would mean that we have to solve this as a quadratic inequality. B squared minus 4ac, which gives, right? Yes. So 6 minus k. So kx squared is, and that means k squared minus 4ac, and 8 times 6 minus k. And this is greater than 0, because it has to be greater than 0. And this leaves us with the equation, and this leaves us with the inequality, actually, the inequality that inequality, and this is actually something that's very easy to factor. Again, this is bigger than 0, so the curve will be sketched like this. You want this part that's bigger than 0, so that would mean that k is less than minus 12, or k is bigger than 4. And k is minus 12 and k is equal to 4, then obviously there is one solution only. Okay. And basically that is how you could approach these types of quadratics problems. Right. The last part of today's discussion is on circles in conjuncture. And basically the whole idea is this general formula for any circle. Well, here you have A comma B is the center, and R is the radius for the circle of the equation x minus a squared plus y minus b squared equals r squared. This is what is called the standard form. Why standard form? Because it is the standardized way where we can easily find the center and radius. Well, expanding everything, leaves you with this guy, and these are constant terms, right? the a squared b squared minus r squared. So really this is a more general form more generalized form in some way. The equation can be turned into standard form by completing the square, which I think most of you are able to do. So basically you have to complete the square for x, complete the square for y, and then basically take everything that's left out, put them into one term, and that would give minus some sort of r squared equals 0. You move that to the other side and you get your radius squared, essentially. For a circle, for circles, for geometry, there are 3 types of problems that you will often face. Number 1 is the finding of the equation of circle based on the properties given. For this, you will have to have a sound understanding of circle theorem. Right? Yeah. For example, something like this. For example, once we already know this, if there's a right angle over there, that is a diameter. So most of the time, this type of question will begin by asking you to prove that AB and BC are perpendicular. From there, you will know that AC is the diameter. Then you can find AC, the midpoint is your center. And then from there, you can easily find your radius. Basically just the length of AC divided by 2. The other type of circle problem of this type is basically you're given 3 distinct points. Right. And from these 3 points, you'll have to find the equation of the circle. In a sense, there's two ways. Number 1 is that you substitute each of the x and y into the standard form, and this will leave you in a set of 3 simultaneous equations in terms of a, b, and r. Well, you'll get the answer, but it's very labor intensive. A much neater way to approach this is through the understanding that the perpendicular bisector of a chord of a circle goes through the center. Goes through the center of the circle, which means that find the perpendicular bisectors of 2 of these 3 points, and another 2 of those points. And the bisectors are really different, of course. 2 perpendicular bisectors meet at 1 point, and that, folks, is your center. Now you have your center, then just use center to one of these trivial points. Find your r. Okay. The second type of problem that IGCSE likes to often give out is tangent line to a circle. Most of you have already probably known differentiation. Well, in a way, because there's x squared, there's y squared, there's no neat way to get the derivative. There's no really neat way. There's a technique for it. It's a JC2 technique, but usually it's not really something you would see often in an AMATS textbook. The AMATS type approach actually uses the center and the point of tangent itself, because by circle theorem you probably already know that the tangent line is perpendicular to the line connecting the radius and the center and the point on the circumference. So it's always a right angle. That means you just have to find the equation of the line connecting the center and the point on the circumference, and then at that point you just find the perpendicular gradient, and then you find the values of C by substituting everything into the coordinates of the point of tangency, which is already given to you. And of course you can show that a line is tangent to a circle by number one, showing that the line is perpendicular to the line at that point to the center. The other way, of course, is discriminant method, b squared minus 4ac, to show whether and to calculate also whether there are 2, 1, or 0 intersection points of the line of the circle. So basically you will have to really master your quadratics if you want to do well in geometry of circles topic. The last one actually involves the intersection of two circles, and you will have to find whether the circles intersect, touch, or do not intersect. Yep. And sometimes you'll also have to find the point at which the circles intersect. The idea is like this. The idea is like this. Yes, basically the whole idea is based on the distance of the radii from the distance of the centers. And this is how it works. If 0 intersections, then the distance between the centers is always less than the difference or less than the sum. If there is one intersection, then it's always equal. And if there are two intersections, then it's always in between. for one last thing, I'm going to show you how to do a little circle conjunction question. This is based on the mathematics PM1 actually. Why PM1? Because really there isn't that much of this kind of stuff that you can find in the normal A-Maths exams, because this is a very new topic. Okay, here we go. The equation of a circle is this. The line is tangent. Well, substitute y into your circle equation, right? Which gives you this thing right here, and by expanding everything, you will get an equation in terms of, you guessed it, a and x. And really, this gives you this. This gives you this value. Here you can find the squared lengths for AC, and then set that to 0, which gives, of course, the following. Hi. And that gives you what it's solved for. This is going to be solved like this. Good everywhere. And this gives you 0, and a is minus 4. The equation for the given value of a find the equation for the diameter, and that would give you a is 0 means that this is only, wow, and that's tangent. Yeah, wow, yeah, half. And so that's your tangent. Half x equals to 0. Well, x and 6 squared plus x squared is 18 by substituting it back to the equation. And now you can just solve this real quick. And here it's pretty much obvious that x is 3 and y is then if x is 3, then y is of course minus 3. Which means that the equation, the answer gives, oh, that's actually being C0. So your equation is y equals minus x. And with that, I hope that you will have understood how to do for geometry for normal maths and A maths. Yep. And I wish all of you the best of luck for your IGCSE exams. Thank you very much for listening, and I hope that this will be beneficial to all of you.